Once we figured out that we need to treat particles on the atomic scale as both waves and particles because their properties, both properties show up at that scale, we needed to change our picture of the atom. We could no longer picture electrons as tiny little particles zipping around the nucleus as Bohr and others had thought of that. We now had to picture electrons as both waves and particles. And so the current quantum model of the atom looks something like this, that an electron actually exists not as a particle circling the nucleus, it actually exists as a spread out, a delocalized wave, what we call the electron cloud. And that wave has a particular energy and therefore a particular size and a particular shape. And the lowest energy wave of an electron is what we call the first energy level. Now, what about the electron as particle? What about particle properties? Well, what happens, we believe, is that when you try to find, okay, where is that electron right now? Where in space, rather than being spread out, where is it as a particle? When you observe the electron, you go looking for it, then it collapses, the wave collapses down, and what we see are the particle properties of that electron. It looks like a particle circling in the first energy level. Now, when the atom absorbs energy, it's not the particle being physically bumped to a higher energy level. What happens is that the electron wave cloud, the electron cloud absorbs the energy, and that actually makes it change its shape, what we call its waveform. And it becomes, in this case, a waveform that corresponds to the second energy level. And now, when we look for that electron, where is it as a particle, it's likely going to show up in what we would see as the second energy level. And so on. And this is in fact how we can explain the double slit experiment for electrons. When the electrons leave the electron gun, they haven't been observed for their location, so they're traveling outwards as delocalized waves, which means when they pass through the slits, they diffract and they interfere with each other like all waves do. But when they hit the detector screen, the detection, the observation of where they are, actually causes them to collapse into a particle state at the detector screen, and that is why we see them hitting as individual particles, but why those individual particles collapse into a way that reveals the wave nature that they had as they were traveling from the gun to the screen.